Hello everyone. Let us see some examples of these scheduling algorithms, CPU scheduling algorithms. Okay, let us see this first come first serve. Okay, so we are given with these 4 processes with their burst times. Okay, so now let us say that assume that the process uh, starts from 0. P1 has been scheduled for execution. Okay, P1 has been scheduled and it will complete it until 10 seconds. Okay, the next P2 will be uh, uh, scheduled and it will continue until 10 plus 4, that is 14 milliseconds. Okay, and then P3 will arrive and P3 will start its execution at 14 milliseconds and it will continue its execution until its completion, that is 2 milliseconds. It will be until 16 milliseconds, and finally P4 will be scheduled and it will complete its execution at 19 milliseconds. Okay, so what is the waiting time here now for P1? P1 starts at 0 itself, so there is no waiting time for this P1, and P2 it's 10 milliseconds and P3 is 14 milliseconds, and P4 started at 16, so it had to wait until 16 milliseconds. Okay, so the total is going to be, total waiting time is something like 10, it's 40, and average waiting time is 40 by the number of processes here is 4, so it's going to be 10 milliseconds. Okay, very simple. All right, so now moving on to another example of this shortest job non-preemptive version. Okay, so here also we have like a set of 4 processes. Okay, so what is this in shortest job? First, the process which is having shorter burst time will be scheduled first. Okay, so let us draw the Gantt chart for this. So it's going to be something like starting from 0. Okay, so which process is having shorter burst time here? P3 is having shorter burst time, so P3 will be scheduled here. P3 will be scheduled here and it will continue its execution until its completion. So it will continue its execution until completion. It finishes at 2 milliseconds. Okay, so this job has been done. Now what is remaining? P1, P2 and P4. Now P4 has a shorter burst time here. Now P4 will be scheduled here. P4 will be scheduled and it will continue its execution until 5 milliseconds and it will complete its part. Right, next job is P2. P2 will be scheduled and it will continue until 9. Okay, and then finally P1 will be scheduled and it will continue until 17. Okay, please make sure that the last time here must be the total of all these. See, 8 plus 4 12, 12 plus 2 14, plus 3 17. Yani all processes should complete at 17 milliseconds. Okay, along with their waiting times. So what is the waiting time actually here? Basically, you see, waiting time can be calculated by using this formula actually. Completion time minus arrival time minus burst time. Okay, now we are assuming that all processes are arriving at 0 milliseconds. Yani it at starting itself all the processes have been arrived here. Okay, clear my point? So now what is the waiting time for this P1? P1 has finished at what? At 17 minus, okay, what is the arrival time? It's 0 minus what is the burst time? It's 8. So it's actually what? 17 minus 8, that is 9. You see, it's P1 has started its execution at 9 milliseconds. Yani P1 had to wait for 9 milliseconds here. The waiting time for P1 is 9. Okay, similarly P2 completion time, when did P2 finish? At 9. So 9 minus 0 minus what is the burst time? That is 4. It's going to be directly, it's 5. So you see, P2 has started its execution at 5 milliseconds, so P2 has to wait until 5 milliseconds. Alright, and finally P3, what is the completion time? It's 2, and minus 0 minus 2, it's going to be 0. That means there is no waiting time for P3. It has arrived and it has completed its execution without any waiting time. Okay, and P4, when did it finish? It finished at 5, and there is no arrival. 0 is the arrival time, and 3, and it has to wait until 2 milliseconds. Okay, so the total waiting time is what here now? It's 14 plus 2, that is 16, and average waiting time is something like 16 by number of processes, that is 4 milliseconds. Okay, understood everyone? Very simple here. And the process, the job which is having shorter burst time will be scheduled first. Okay, and there is no preemption here, non-preemptive. Okay, so let us go to the other algorithm, which is preemptive version. Okay, so now let us say starts from 0. All right, so in the preemptive version, what happens is it looks for the shortest job first, but based on their arrival times, like if any process with a shorter burst time has arrived, the current process will be preempted. Yani it will stop its execution and give preference to the process which has arrived with shorter burst time. Okay, clear my point? Let us do the example here, you will understand it. So let us say here P1 has arrived at 0. Okay, the arrival time of P1 is 0. Okay, so as soon as P1 has arrived, yani we have to check the available process. Now if you see here, only P1 is available at 0 milliseconds, remaining are not haven't arrived yet. Okay, so at P1 at 0, only what is the process available? P1 is available. So P1 will be scheduled directly, irrespective of its burst time. Anyway, we are not concerned with now here. We don't have these values actually. Only P1 is available at 0. Understood my point? At 0 arrival time, at 0 milliseconds, there is only one available process, that is P1. Okay, and now P1 will be scheduled, but it will be the process P1 will continue its execution, let us say for 1 milliseconds. Okay, and why? Because at 1 another process has arrived, that is P2. Okay, so at 1 milliseconds P1 has done its job, and it has become 7 now. Okay, see, it has become 7 milliseconds now. 1 millisecond has completed its part of the job will be finished here. Why? Because now P1 will be preempted and P2 will be scheduled. Why is it so? Because at one arrival time, what happened here? P2 has arrived with a shorter burst time. Now if you look at this 4 and 7, which one is having shorter burst time? 4 is the shorter burst time. So P2 is having a shorter burst time than compared to P1. So that means P1 has to stop its job and P2 will be given the preference here. Okay, so now P2 will be given the preference and it will be scheduled and it will continue its job until 2, because at 2 another process has arrived. Okay, now at 2 you can see here P2 has finished 1 milliseconds. The remaining time here is 3 milliseconds. Now at 2, what is the burst time of P2? It's 3 milliseconds. And what is the burst time of P3? It's 2 milliseconds. Now which one is shorter? P3 has a shorter burst time. Now P2 will be preempted and it will be forced to stop and P3 will be scheduled for execution. Why is it so? Because P3 is having a shorter burst time. Okay, so now P3 will be scheduled here. P3 has started its job. Okay, and it will continue until 3, because at 3 another job has arrived here. Okay, now you see this one will be at 3. What is the remaining time what is the remaining time left for P3? It's 1 milliseconds. Okay, and now at 3 milliseconds, what is the remaining time for P3? It's 1, and another process P4 has arrived. So now that means P4 is having shorter burst time than this P3? No. Okay, if it is not having shorter burst time, then the current process will continue its execution. There is no preemption here. When preemption will occur? When a process with a shorter burst time arrives. In that case, okay, the current process will be preempted. Clear my point? So now P3 will continue its job of remaining 1 milliseconds. So now you can say it as until 4 P3 will continue. Okay, so that means P3 has finished its job. Alright, so now you see at this time there is no checking of any other new processes, because all processes have arrived at this 3 milliseconds. Okay, so there is no checking of any other available processes which is having a shorter burst time. Now we need to check which process is having shorter burst time. Now you see P2 is having 3 and P4 is having 3, so anyone can be scheduled here. So now let us say P2 has arrived earlier, so this P2 will be scheduled and it will continue its job until 7. Okay, this job is done. Alright, now then P4 will be scheduled. P4 will be scheduled and this is also done. So how long it has to continue its job? Until 10 milliseconds. That is 7 plus 3, 10. So what is remaining now? P1 is remaining. So P1 has how many left? 7. so it will be 17 milliseconds. All right. Okay, so by 17 all the processes has finished its job. Now you see 8 plus 4 12, 12 plus 2 14, 14 plus 3 17. Clear my point, everyone? Right. Okay, so now we have to calculate the waiting time here. First we need to find out the completion time minus arrival time, and that is turnaround time. So what is the turnaround time for this P1? When did P1 has finished its job? It finished at 17. It finished at 17. What is arrival time? It is 0. And what is the burst time? It's 8. Okay, don't confuse with these numbers, please. This is the remaining time that we have learned. So the total burst time for P1 is 8. So it's 17 minus 8, that is 9 milliseconds. Okay, next, what is the completion time of P2? P2 finished at 7. Okay, and what is the arrival time? It is 1. And minus, what is the burst time? It's 4. So it's actually 7 minus 1, 6, 6 minus 4, it's 2. Okay, right. When this P3 has finished, it finished at 4 and minus, it arrived at 2, and the burst time is also 2. So it's going to be 4 minus 2, and 2 minus 2, it is 0. So that means you see P3 did not wait for any time here. As soon as it has been scheduled here, and it has continued its job until 4. So there is no waiting time for P3. Alright, now P4, what is the completion time? It's 10. It's 10 minus arrival time is 3 and burst time is 3. So 10 minus 3 7, 7 minus 3 is 4 milliseconds. So P3 had to wait, P4 has to wait for 4 milliseconds. That means it started its job over here at 4, okay, and it has to continue. It had continued its job until 10. Okay, so the average waiting time is what? So total waiting time is what? 9 plus 2 plus 0 plus 4. Okay, so average waiting time is equals to something like 8 plus 3 plus 9 plus 2 11, 11 plus 4 15, 15 by number of processes is 4. So 4, 15 divided by 4 is what? It's something like 3.75 milliseconds. Okay, understood? Preemptive version. Okay, let us take another example now. Let us take it with 5 processes. Okay, and we say that it's arrived at 1, arrived at 2, arrived at 3 or 4. See, it can be something like 0.4 also. 0.4 means at 0 to 0.4. At 0.4 you have to wait it over here. Okay, that is little complex. Let us do with simple 1 unit of time here. 0, 1, 2, 3, 4 arrival times. Okay, I'll explain the complex one later on. So now let us assume that at 1 unit of time, line by line, the processes have arrived like 0, 1, 2, 3, 4. Okay, and let us say the processes P1, P2, let me make it as like 9. Okay, let's set something like 9 or 8, or okay, let me set 2, 1, 3, 2, and 6. All right. Okay. Let us say it is starting from 0. P1 is available at 0 time, and it will continue its execution until 1 millisecond. Okay, and you can see here at 1 millisecond another process P2 has arrived, and it is having shorter burst time, that is 1 millisecond, than this 7. You see, the P1 at 1 P1 has 7 milliseconds remaining time now. Okay, so now if you compare this 7 and 1, P2 is having shorter burst time. At what time? At 1 millisecond. Okay, so if at 1 millisecond P2 has arrived with a shorter burst time, so P1 will be preempted. P1 will be forcibly stopped, and P2 will be scheduled here. So let us schedule the P2 process, and it will continue its job until 2 milliseconds, because at 2 milliseconds another process has arrived, and you can see here there is only 1 millisecond, so that means P2 has completed its job. P2 has completed its job. There is no logic of preemption here. Okay, so now P3 has arrived at 2 milliseconds with shorter burst time as 3. So what are the available processes now at 3 at this hour, at this point? At 2 milliseconds, the available processes are P3 and P1, because P2 has done its job, has completed its job. Okay, P3 and P1 at 2 milliseconds, all these processes have arrived. So now we have to check this time with the available processes here. So which one is having shorter burst time? Of course P3 is having shorter burst time, which is 3 less than 7. Okay, so P3 will be scheduled here. P3 will be scheduled, and it will continue its job until 3 milliseconds. Now at 3 milliseconds, okay, this will be 2 remaining time now. Now at 3 milliseconds, P4 has arrived, okay, with 2 milliseconds again. So which one is having shorter? Both are equal. So the P3 can continue its job here, or P4 can be scheduled. Both are the same. Okay, let us assume that it's having 1 millisecond. Now which one will be scheduled? Which one will be scheduled now? P4 has to be scheduled, because P4 is having lesser burst time now than this than the P3. Okay, so let us say P4 will be P4 will be scheduled here, and it will continue its job until 4 milliseconds, because it's having only 1 millisecond and it also has completed its job. Now at 4 milliseconds, which process has arrived? 6. But it is having lesser burst time? No. Which one is available? All processes have arrived at this point now. So now we have to look which process is having lesser burst time. Which are available now? P5 is available, P3 is available, and P1 is available. So P3 having a shorter burst time. Now it has to continue. That is P3, and it will continue until its completion. So this job is also done. Now what remains? P5 and P1. So P5 is obviously shorter burst time. So this also will finish until its execution. That is P5, 6 plus 5, that is, sorry, 6 plus 6, it will be until 12. Then P1 remained with 7, that will be 19. Okay, so P1 also has finished its job. Now what is the waiting time for P1? The completion time is 19, arrival time is 0, burst time is 8. So it will be 19 minus 8, it's 11 milliseconds. Okay, and what is P2 completion time? It finished at 2 and it arrived at 1, and what is the burst time? It's 1. So 2 minus 1, 1 minus 1, 0. Yani no waiting time for P2. When did P3 finish? It finished at 6. So 6 minus arrival time is 2 minus what is the burst time? It's 3. So 6 minus 2, 4 minus 3, that is 1. So P3 had to wait for 1 millisecond. And then P4, when did it finish? It finished at 4. What is the arrival time? It's 3. And what is the burst time? It's 1. So 4 minus 3, 1, 1 minus 1, 0. That is no waiting time for P4. And P5 finishing time is 12. Completion time, arrival time is 4. And what is the burst time? It's 6. 12 minus 4 is 8. 8 minus 6 is 2 milliseconds. So the waiting time for P5 is 2 milliseconds. Okay, so total waiting time is 11 plus 1, 12, 12 plus 2, 14. That is, average will be 14 by 4. Okay, 4 3 is 12. 6 something, 3.6 milliseconds. Okay, hope you understood this preemptive version. Please, shortest job preemptive. This is also called shortest remaining time first algorithm. So if there is any clarification or doubt, I will try to clarify it during our theory session. Okay, we have another type of algorithm, that is round robin algorithm. We will continue that in the theory session, inshallah.